All right, so our last one here is on algebraic properties. So this one is very definition heavy. These are all properties that you're used to using. We're just giving them formal names. So when we use those names later on, you guys should be able to remember, hopefully, or at least remember we talked about them. Okay, so the first three big ideas are commutativity, associativity, and then kind of pairing with that is distribution. But let's focus on those first two. So commutative, I forgot an I. Commutative is like commuting. So when I commute to work, I get in my car and I move my place. Associative properties, I really should say are up there. Right. Associative properties are about who you're associated with. Like you associate with the right kind of people, you're in their group. Group like grouping symbols. Math grouping symbols are parentheses. Okay. So commutative is about things moving. So if I'm looking at the commutative property of addition, the things I'm adding are going to change order. If I'm looking at the commutative property of multiplication, the things I'm multiplying are going to change order. Now, these are things we know. We know we can add in either order. 1 plus 6 or 6 plus 1 is 7. I can multiply in either order. 2 times 3 or 3 times 2, both of those multiply to 6. So we do know these properties. We're just giving them formal names and asking you to distinguish between them with a weird list like this. So we're going to do the whole list. That'll make this video a little long, apologies, but better it's all one and done. So our first one here, 5 plus 2 equals 2 plus 5. My numbers have swapped places. So this is commutative. And then the operation here is addition. So this would be the commutative property of addition. Now down here, 5 times 2 equals 2 times 5. Again, my numbers are moving. So this is another commutative property. But here we were looking at multiplication. Now, when you guys are writing your notes, we're not going to pick up your notes for a grade. These are very much you making your own reference sheet. So later on, when you look at it, you know what you wrote. So if you just want to write like COM prop of MULT, cool. Just as long as you remember what you're going to have to click or fully write out on your writing assignments. Or for the course fundamentals mastery assessment. All right, so we got our first two, commuting. Our next one, 2 plus 3 plus 5 equals 2 plus 3 plus 5. So there's not a good way to say that without actually saying parentheses in there, which can get a little weird sounding. But here, what you should notice is the parentheses are moving. Parentheses are about grouping. So first we have 2 and 3 grouped together, and then it's like, nah, just kidding, 3 and 5 grouped together instead. Now we know the order you add things in doesn't matter. It's going to give you the same result. So these parentheses can move like this. But what's changing is what's being associated. So this is the associative property of, and then we were looking at addition here. Likewise on D, the associative property of multiplication. Now, if you are shorthanding this, I recommend not writing ASS for associative, and you know why. So if I'm shorthanding this, it's ASSOC, so the ASSOC property of addition. But I mean, it's your note, so if you want to write AS, you can write AS. Now, E, and if we look F, have to do with addition and multiplication. So this is a special combo property. And if you look, we had the 2 outside the parentheses, and now the 2 went to everybody inside the parentheses. So we call that distribution. So just like when you distribute papers in class, everybody gets one. Same thing here. Distribution property is inside parentheses. I'm sure the book had a much better looking definition. That's just my quick stab at it. Now, like technically what the book did here is they put subtraction on F, so they're going to say the distribution property of multiplication across addition or of multiplication across subtraction. Usually though, we don't consider subtraction its own thing because we just think of that as adding a negative number, so it's really just the distributive property of addition. And just knowing distributive property here is good enough because there's only one of multiplication across addition. And then I'm just going to be really lazy because I'm using a computer. I'm going to control copy, come up here, control V, subtraction, and just change it to subtraction. There. But just being able to call that distributive, good enough. Now, the reason the distributive property is such a big deal is this is the basis for all of our factoring. So multiplying out, I start with large stuff in the parentheses, and then I'm left with a whole bunch of small products. But if I look at it backwards, small products, and I pull out what they have in common, factoring. So seeing our weird quadratic factoring as undoing distribution, like that can help, but it's also kind of weird to see it that way, and it's not the way it's usually taught. So don't worry if you're like, I don't know what she's trying to connect here. I'm trying to preface something for later. We'll be fine. All right, now our last ones here are dealing with 2 more properties of numbers. So there are 2 special numbers within addition and multiplication. So the identity element is the element that doesn't change when using the operation. That doesn't change anything else. So for addition, the identity is 0. For multiplication, the identity is 1. Now, when we're looking at what does this show, what we're having to contrast this with is the inverse of a number. And it does tie in with the identity element. So the inverse of a number is what you combine with the original number to equal to the identity element. So notice I finished this with equal to the identity element. So when we look at these, the first two are equal some random numbers. The second two are equal 0 and equal 1. That's your big, like, just visual flag for how to tell the difference. Now, these are all ideas you guys are familiar with. Like if I'm thinking of 7 and I need, I'm adding 7 to something, canceling that would be subtract 7. If I'm multiplying by 4, canceling that would be dividing by 4. You guys know inverse operations already. This is just the very formal mathematical definition. So our inverses here this is typically written as a plus, and then we write negative a in parentheses equals 0, where a can be any number. So 2 plus negative 2, that equals 0. 3.5 plus negative 3.5 equals 0. Pi plus negative pi equals 0. Doesn't matter what a is. For multiplication, we write, sometimes they use a, sometimes they use b. I'm going to use our asterisk. Really, we'd use the dot. 1 over b would equal 1. So 2 times a half, or 3/5 times 1 over 3/5 is going to flip 5/3. We're going to deal more with fractions next class, but that's what the 1 over means. So typically, though, we're just going to use like 2 times 1/2. Just integers for the first number, so you're not having to worry so much about the fractions. Okay, so when we have the identity element interacting with something, that's showcasing what the identity element does. Now, I don't remember if the book calls this like the identity property of addition. And then down here, like the inverse property of addition, maybe like, like those are really the words you need to know. Identity element property of multiplication. And then down here, the inverse element property of multiplication. Usually, though, we'll call those multiplicative inverses, additive inverses. But like I said, you guys are familiar with these. We're just giving them the formalized math terms, and that is your dictionary to mathematical terms. Think of math as a foreign language. Think of this as like your first list of definition terms, except we don't make you memorize anything. You are going to get to use your notes on all quizzes, all tests. So you just have to have it organized and you know where it is. All right, so that's it for our first set of lectures. I will see you guys in class or in the next videos.